Oh, look at the time. All kinds of science on my mind. Turn up the frequency sessions. It's time for Vlad's laboratory lessons. Who's ready to do science? I know I am. Welcome to another laboratory lesson. I'm your host Vladamir, and we today, on this super special day, are going to conduct our first Minecraft experiment. Ooh, why is there a lemon growing out of my wall? Something to look at later. Probably radiation poisoning. Anyway, yes, we are going to learn all today about what it is scientists really do. Why is it the stereotype, the mad scientist with his kooky experiments always creating monstrosities? Well, it does not always have to be that way. Actually, it starts out at a much humbler, simpler premise of finding a problem and trying to solve it. You see, as scientists, we try to help out. You know, everybody, they try to do their part. But as scientists, oh, we can do a big part. Because we know how to manipulate numbers. And with our logical minds, it's not really super skill. But really, it is just a matter of thinking. Our logical minds can help us organize these experiments in such a way that we can help out the world. For example, there is no drug today out on the market that is approved by the FDA that has not been tested thoroughly by numerous lab groups. And when I say thoroughly, I mean thoroughly. And this is done multiple times. That is something you'll hear in experimentation a lot, that experiments, when setting them up, must be repeatable. And the reason for that is this way it eliminates any possibility for biases. If there is a suspicion that those results were doctored and falsified, then other experimenters can read the lab report, do exactly step by step the experiment that the original experimenters did, and then they can see if it is really a valid result, if they happen to get the same thing over and over and over again quantitatively. So today's experiment, we are testing different soil types, okay? We've got our control group here, which I'll talk about in a moment, and it is dirt. We're trying to see what soil's going to be the best to grow a Minecraft tree. I think that this is going to be the best. It is my hypothesis that this will be the best, based on the evidence that I've seen in Minecraft of this only being the only soil type that grows trees. Pretty good hypothesis, right? I know, you may not know what the hypothesis is, but hold on, comrades, we're getting there. A sponge, I don't know, but, you know, we base this all off evidence, and since there's not a real big database on growing substrates for Minecraft, I'm gonna say it's gonna suck. I'm really thinking this is the only best one, because why would this tree grow on a sponge, really? If it did that, it would hang around a dish sink or something, I don't know. But netherrack, probably not. It is hard lava rack from the nether. I doubt it is going to give us any burgeoning tree growth. And sand. I almost feel more hopeful for sand because I live in New Jersey, where we have these things called the pine barrens. Many pine trees, very big, very tall, very wide too. They grow in the sandy soil, so this might do okay. Who knows? Okay, so that is these three are our experimental groups, because the dirt is our control. And what the control is, it's something, well, you control that you know the results too. We know that dirt is going to give us a positive growth result for a tree. We don't have to test that. It is already proven to us by nature. What we do have to test, though, are the other possible experimental group substrates like the sponge, the netherrack, and the sand, because we're not so sure. And that is what we are trying to figure out here today. That is the problem we are trying to solve. So maybe you could start to see this is already starting to formulate. I mean, yes, I did preset these so we could just jive and go, but you can see how this experiment is coming together. Now, other than the control group and the experimental group, what are you measuring? What is called the dependent variable. And in this situation, we're going to be measuring the length and the width of the tree trunk growth. Whichever one has the highest and largest width is going to be the best soil substrate. So dependent variables, really, it is just the thing you're measuring. Control, it's what you control, it's what you know is going to happen, and experimental groups are the thing you're experimenting on. What are these new variables going to do? What kind of dependent variable, what kind of measurement are we going to get out of these experimental groups? Now, there is a method to science, there's a method to everyone's madness, and our madness is the scientific method of madness. It is find a problem. We already talked about that. We ask questions. You ask questions based on empirical data gathered by many other scientists. That's why you probably heard the phrase, science is built on the backs of giants, because gigantic scientists like Carl Sagan and Richard Feynman, I don't know why I was going to say someone else that was not a scientist, but I caught myself there. And all these peoples, many peoples, over many centuries, helping out the field of science, helping out really the world, helping out humanity, because remember, science strives to answer problems, even if they are problems that people think we should not be answering, like, oh, what happens when we smash two very high dense particles together? Does it make a bang? Does it make a black hole? Okay, well, those are ethics. We'll not talk about that here. This is the method, not why we do it, but this is the method. This is how we do it. The hypothesis, I mentioned this before, that being my hypothesis was that dirt substrate is going to be the best, based on the evidence I've seen around the Minecraft world that it's the only growing source for a tree. So now that we have our hypothesis, we think this is what's going to happen, we experiment. Now it's important to know that even though we have a hypothesis, as I bring up before, the biases. We don't want to design our experiment in a way that's going to be biased to prove our hypothesis. In science, being disproven, comrades, is one of the most amazing things, one of the most enjoyable things, because it means there's more to learn. There's more layers of the onion to peel back to see the delicious core, or to get disgustingly smelly onion hands. Either way, it means that our work is not done yet and we need to experiment more, which is a labor of love. It is a labor of science. So we need to design our experiment that it is not biased. We need to make sure we can reproduce the experiment too. It can't be one phenomenon happening every 200 years. Has to be something that you can actually test, something that you can measure in a dependent variable quantitatively. That's an important thing. Don't go off qualities. I mean, you can look at the leaf color and all that, but these things are kind of subjective. You want cold, hard data. Leave the qualitative stuff for the lab report, filling in your discussion section. Don't worry about talking about that here. And then you run the experiment. Once it is run and we see what happens, which we will, we make our conclusions. Was our hypothesis correct or was it incorrect? And then we tell our colleagues why, because in science, the reason we have gotten this catchphrase of science being built on the backs of one another's ginormousness is because we always share our results. If we hold our results, it is useless. Thinking that you're gonna wait and find a better time to publish these results is silly. Somebody else is gonna do science quicker than you and find what you were looking for. Another important thing to mention, as we hop into this time machine here, which will thankfully speed this up so we can see the results. You want to make sure that your experiment has not already been done by other giants. So do your research, comrades. Do your research. Let's get this time machine going. travel! Okay, comrades, let us see what our results have. Oh boy, it looks like our hypothesis was already disproven. I can't believe this sponge, she grew so tall. Oh my goodness, look at this, and the wide too. The width of this thing is great as well. Now, this is what I'm talking about when I mean know your variables. Yes, this is the fattest width tree, but it is not the height. It does not have the height to give it the superiority over this winning substrate, being the best for growing trees in this experiment situation. Let's see how the other competition fared. Not so well. Dead as a desert. Okay, I guess my Pine Barrens theory was disproven, but it is important. This is why the scientists get paid the big bucks and why peoples are just like, science, I could do it if I chose, but I don't. What is important now is taking these results, taking this understanding of what we've just done here, and writing it into lab report, writing it into a presentable format for our other scientific comrades to conspire amongst, to understand what we did, to repeat our experiment just in case, to make sure it is really very, very solid. The more results you have, the more quantitative data you've taken, the better off you can be. Also, the more variables that you eliminate, and by variables I mean things that could possibly change, like the growth rate of the vegetation. If I put a watermelon there, a pumpkin there, a tree in this slot, and then a cactus here, that is a horrible experiment. That is unacceptable, comrades. You don't have your variables under control. Too many variables you have with so many different vegetation. Each vegetation has its own set of growing circumstances, so you want to keep it all the same tree like we have in this situation. But that is why we do science, why we publish our results, and why we do it again and again. This is the endless testing that scientists do. I'm Vlad Z. I hope you've gotten a better understanding of how to do experiments. Please tell me, comrades, in the comments below. If you had an experiment, what would you do? Even one that is doable. If you had a lab or something, let me know below in the comments section. Tell me, what is your dependent variable, what is your control group, and what is your experimental group? I would love to know. What was that?
Well, look who it is. The loud one. Almost ironic that you escaped my lab only to build your own. However, I cannot let you continue to do science without my gentle guiding hand.
You monster! I thought you let me go.
I can't have you running around giving out science secrets as if they were free lemonade from a freshly crushed lemonade stand, complete with struggling children trapped beneath a bus. This cannot continue.
No!
Go ahead. Try to run. That's what makes this oh so fun.